Creating realistic physics simulations in games involves advanced techniques and considerations to ensure that virtual objects behave believably within the game world. Here's a step-by-step guide to achieving this. Choose a physics engine. Select a robust physics engine like Unity's PhysX, Unreal Engine's PhysX, or Havok, which provide built-in tools and libraries for realistic physics simulations. These engines handle complex calculations for collision detection, rigid body dynamics, and interactions between objects. Set up collision detection. Implement accurate collision detection algorithms to ensure objects interact realistically when they collide. Consider factors like object shapes, convex, concave, mesh complexity, and the environment's physical properties, friction, elasticity. Implement rigid body dynamics. Define physical properties such as mass, inertia, and center of mass for objects. Apply forces, gravity, friction, and torques, angular forces, to simulate how objects move and rotate in response to external influences. Consider fluid dynamics. For games involving liquids or gases, simulate fluid dynamics to mimic realistic behaviors such as flow, viscosity, and buoyancy. Use particle-based systems or fluid simulation techniques to achieve fluid-like movements and interactions. Apply constraints in joints. Use constraints and joints to connect objects and define their relative movements. Implement hinge joints for doors or rotational constraints for vehicles to simulate mechanical interactions realistically. Optimize performance. Physics simulations can be computationally intensive. Optimize performance by adjusting physics settings, collision shapes, resolution, implementing LOD, level of detail, for complex physics interactions, and using multi-threading for parallel processing. Test and iterate. Conduct extensive testing to validate the accuracy and realism of physics interactions. Adjust parameters, fine-tune forces, and refine collision behaviors based on feedback and testing results. Integrate with gameplay. Integrate physics simulations seamlessly into gameplay mechanics to enhance immersion and gameplay depth. Design puzzles, challenges, or combat scenarios that leverage realistic physics interactions for engaging player experiences. Realistic feedback and effects. Provide visual and auditory feedback to enhance the realism of physics interactions. Use particle effects, sound effects, and dynamic animations to convey impacts, collisions, and physical forces effectively. Continuously update and improve. Stay updated with advancements in physics simulation technology and techniques. Incorporate new features or optimizations from physics engine updates to improve realism and performance over time. By following these steps and leveraging advanced physics simulation techniques, game developers can create immersive and realistic gameplay experiences where objects interact authentically, enhancing player engagement and enjoyment.